I've been hungry for like an hour already.
I'm recording now.
Okay, cool.
Guided almost all of that.
What I wanted to say is like, it's great that he starts off with like the previous positions, because in some way you're actually addressing the initial premises of the person you're trying to teach as well. Because what we did with Argenti was like, we start off with our position and he brings up all of these false premises that we have to address now.
Yeah.
So, yeah.
About thinking on this problem for 300 plus years. Here's the ghost in the machine. Picturesquely, the ghost is in an inner room. Contact with the world is by means of a TV screen and speakers. Descartes, in his Genius, this is what he told us. The first grade of sense is approachable strictly through mechanics, strictly through physical laws, as he remarked. What we have to ask, and think of the beauty of the way he phrased it, what we have to ask is how the motions of light become the motions of nerves. That's a problem of mechanics, or hydraulics, depending on which particular metaphor you chose. The second grade of sense he recognized was a hybrid, but nonetheless science could approach it, he suggested. The question here is, how do the motions of nerves become secondary mental qualities? Color, in the case of vision, for example. Pitch, in the case of hearing, for example. To these first and second grades of sense, the pure physical and the hybrid mental physical, he suggested what is perhaps one of the most important metaphors, suggestions, expositions ever in the history of science. He said, I should like you to consider that these functions follow from the mere arrangement of the machine's organs every bit as naturally as the movements of a clock follow from the arrangement of its counterweights and wheels. This is the machine metaphor. And it's hard to imagine that our science...
The position, I'd like to say that the position as well is still meant for the purposes of then dismantling it.
What did you say?
I'm saying the position is still meant, like the best case is provided for the for like the student, so it can be then dismantled in a way that leaves no wiggle room for anything.
Yeah, Turvey's great at steel manning.
Science of today could have got anywhere without it. But it is a metaphor of a long history. And I would like us to consider the possibility, which I'm not alone in asking you to do, that this metaphor is now in the way of advance, not part of the means of advance. Here are the assumptions that the founding fathers of the mechanistic philosophy gave us. The locality assumption. All causes are local. All causes are by contact. So in order to sort of address perception, if there is some object to be seen, then what I need is a simulacrum of that object. In modern terminology, we might say a representation. But there are many terms we could use for this. But this must occur, according to the notion of local causality. It must occur because, given two things A and B, A must make physical contact with B, must be contiguous with B, if it is to cause a change in B. This is the locality assumption, tremendously powerful and terribly important. The matter assumption. Matter, the 17th century founding fathers of the mechanistic philosophy told us, is passive, inert, has no self-motion, no self-cause. They had to argue this. They had to. They had no option here. If the thing moves itself, they then contended, then one part of the thing must be the mover, and another part of the thing must be that which is moved. This is how you solve the absence of self-cause and self-motion. In terms of the ghost in the machine, it looks like this. The ghost is the unmoved mover. And that apparatus, on its little wheels, or a ghost in machine is living in some sort of mobile home. Right? The ghost inside the thing, this is the mood. Look at it here. This is modern neuroscience. Frontal lobes, howls, the unmoved movement. And then parts are moved, brain and body. This is how we are forced to handle this problem. We have
I'm not talking so much right now because I'm
acts as the unmoved movement.
What?
Oh, sorry.
No, I'm not talking so much right now because I'm cooking food.
Okay.
Okay.
The matter assumption. There are entailments. And these entailment assumptions, again, are tremendously influential, and without them one could not imagine that we could have progressed to where we are today. Here's the genius of Newton. Single entailment mode. Present entails the immediate future. And this is how he couched it. He encoded environment into force, and he encoded into formalism, and he encoded system into a formalism, in which the only entailment, Newton's genius, is a recursion law that takes speed and position being x subscript 0, speed x prime subscript 0, and it makes it into the next immediate position and next immediate speed. In order for us to pull off this entailment, it required that we develop a particular mathematical apparatus that would permit us to have access in a way that we could manipulate and play with this entailment, the calculus and its paraphernalia. Along with this essential entailment is the following: only efficient cause is properly causal. The 17th century fathers of the mechanical philosophy, as they were seeking to, as it were, release themselves, make themselves liberated from the constraints, as they saw it, of Aristotle. These are Aristotle's causes. And it's only the hammering and the chipping at the material, giving shape to the statue, that's permitted under the Newtonian formula. It was a brilliant move. But we may have need for concern to worry about how in modern science Aristotle's other causes are allowed back inside a proper formula. Causal chains flow from parts to whole, argued the founding fathers. Subsystems to system, and never vice versa. The green arrow is acceptable, the white arrow is not acceptable. And this is the claim for no reflexivity, and this issue of no reflexivity is part and parcel of the problem of self-motion and self-cause. They belong to this problem of reflexivity. The component assumption. Components are absolute and context independent. Functions are entailed by components. In my diagram, C is component, F is function. Components entail functions. From Descartes onwards, we have been beloved of the grandfather clock. It is a magnificent paradigm of the machine metaphor. Look what it does to us. It can be fractionated. When I fractionate it, the parts exist independently of the whole that they constitute. They still entail the same functions. Pick them up, put them into place. Take a clock, fractionate. Take an automobile, fractionate. Then synthesize, put the parts together again. In this metaphor, fractionation or analysis and the notion of synthesis are purely reciprocal. You take a part, reverse the process, and put back together. This is the underpinning to a very powerful assumption, the paradigm of principal superposition. The paradigm of the principle of superposition is what this is. And of course this is reductionism. This is the genius of the machine metaphor. And sitting in there is a very powerful claim, one that is terribly problematic for most of psychology, physiology, biology, zoology, and that is context-independent parts. So here's the 17th century mechanistic hypothesis. I claim, and I think it's not unreasonable, The local contiguous cause and the added assumption of inert matter prescribe the ghost. That is, they demand the ghost, they invite the ghost, they encourage the ghost, they won't let you get away without the ghost.
Look what assumptions, look what problems they run into from their assumptions. Yeah.
What'd you say?
He's saying, look what problems we're running into if we use these assumptions.
Mm.
So you should we establish the assumptions and we establish the problems that flow from them.
Entailment is recursion, no reflexivity, and the request for context independence of parts. These prescribe machine. And together, something interesting, I think, follows. The psychology can be called contact psychology. It's a psychology whereby we try to understand all processes in terms of contact. In cognitive science, it is required that I find a local, contiguous cause for whatever it is I'm currently doing. A local, contiguous cause. It is a brilliant theme, but it contains within it, I think, certain problems, one of which is James Gibson hasn't got a hope. You cannot get an intuition about direct perception from this frame of reference. You cannot do it. You cannot do it comfortably. You cannot do it sensibly. Indirect perception is what falls out of this story. So let's consider a potential 21st century non-mechanistic hypothesis. I say potential because I don't think there's any way we can know what will transpire here. The 21st century is new, and we have inherited a wild zoo of brilliant notions from the 20th century. They have played almost no role in how we think about matters psychological and matters biological. Jimmy Gibson used to say that one of the odd things about psychologists is they have no respect for their problems. I think he was right. They think their problem is such that you can teach undergraduates simple courses and hope they will unlock the deepest problem in the universe. The concept required for psychology must be damn hard, it must be immensely complicated. And no undergraduate curriculum even comes barely close to giving students any idea of what's going to be involved, I think. Non-locality and active matter. I would like to claim that these notions, beginning to show up and gain force in the 20th century, proscribe ghosts. And I would like to think that multiple entailment modes, the acceptance of reflexivity and the fact of context-dependent components, I think these prescribe machine. And in this discourse, by the way, as I've given this sort of talk around the United States of late, I say that the real challenge here is the machine challenge. I think we're sort of happy with the idea of getting rid of the ghost. The idea of getting rid of the machine is a whole different story. What does this yield? It yields what we might call non-contact psychology. And I think in here sits direct perception. To put it another way, if Gibson's hypothesis of direct perception is going to have any hope, I think it only has a hope in this framework. Here's one of his problems. Excuse me. Easy to do. Here's one of his problems, the so-called scanning problem. In this room, as I stand here right now, I am about to scan this room. And I have a perception of the room. I'm about to scan this structure here, and I have a perception of the structure. This is how...
Now that the two main positions are established, we're going over examples. So now we can get onto examples and analyze them through two potential frameworks.
We handle it in psychology. The sequence of samples is identified by the tau value, the time value. So there's a sample at time 1, sample at time 2, time 3, time 4, etc., and I collect them together into a short-term memory. I sum these samples, and I therefore have, in short-term memory, a composite of earlier and later samples as they coexist in this structure. The purpose of this line of reasoning is so I can satisfy the requirement of local, contiguous cause. What gives me the perception of this room? I have pulled together the samples, I've used some integrator, and the moment in my head is the image of the room, which is the cause of my perception of the room. But Gibson was a weird bugger. He was a weird bugger. He said things like this. He said, I don't think you need to assume that perception requires a simultaneous composite in the brain. If the sequence contains the scene, it doesn't have to be converted into it. Those are so radical, those sentences. Look at what the greatest commentator on 20th century and 19th century psychology remarked. This is Boring, Edwin Boring. No one surpasses Boring in his grasp of the development of our science. Perhaps Gibson could ultimately win our assent to a temporal vacuum between cause and its effect, but it would require revolutionary thinking. So he put his money on it, put his finger on it. He put his money on it, put his finger on it, that's for sure. He put his finger on it. He said that what Gibson's asking for is a non-contact psychology. That's radical. This is 1967, Gibson's book is 1966. In 1964, a very different part of science, the locality assumption was being challenged. There are some causes that are not local. There are some causes that are not by contact. And in many respects, this follows from the genius work of John Bell, the Northern Irishman. It's a good representation of Northern Irish in this movement. Northern Irish scholar. Here's Bell's inequality. Let n be number, and let A, B, and C be the parameters of some objects in a class. So imagine there are 40 of them, there are 2,000 of them, there are 1,000,000 of them, but you can classify them according to A, B, and C. So Bell's inequality reads, in its beautiful simplicity, the number of things that have parameter A and not B, plus the number of things that have parameter B and not C, is greater than or equal to the number of things that have parameter A and not C. There's nothing fancy about this. Make up any 3 parameters in this room. Male, taller than 172 centimeters, blue eyes. Make that up, do it in this room, Bell's inequality is satisfied. It has nothing to do with quantum mechanics, although that's its target. It has nothing to do with quantum mechanics at all. It's a remarkably simple expression that captures, embodies everything we believe about science. Property things exist independent of or prior to observation. Inductive inference is valid, and the principle of local causality holds. In the latter part of the 20th century, we used a mixture of various notions and devices. These are spins up and down of electrons. The things in the middle, the Stern-Gerlach devices, are kinds of registers of particular spin values. In the case of a upward arrow, that means we have a magnetic field running upward, and spin up means it's parallel.
Yeah, everything that he's saying here,
down is anti-parallel.
is explained in like much greater detail in like lectures on perception and lecture 5.
I'd say it's
Like,
useful to like introduce the underlying concepts.
Yeah, no, I'm just saying like he explains it better, like fuller in
Yeah.
lectures on perception.
I understand, but like I think what you should do in like some on the side that we're gonna do, we can briefly explain the underlying concept behind non-locality and link the lectures on perception stuff and these researches.
And Mr. Bell suggested that we pack these things together and put them in the context of the suggested Gedanken experiment by Einstein, Podolsky, and Rosen, EPR. And if you do that, then you can reformulate in a testable way Bell's inequality. This is what it looks like, in the form appropriate for experimentation, using those three diagrams that sit above it. And then you apply quantum mechanics. Quantum mechanics has its rules, and it says, let's apply this rule to this little story of Mr. Bell, and what happens when you do that? When you do that, quantum mechanics comes out with the following answer. The sum on the left is not greater or equal to the sum on the right. Bell's inequality is not satisfied. So this is what he created it for. He created this inequality so he could build experimental tests. Bell's inequality is not satisfied. Since 1980, this is a repeated finding. You can separate these entities. You see these two devices here? They can be separated by orders of 10 to 20 kilometers. Bell's inequality does not hold. What's the problem here? What's wrong? Is it the realism assumption? Is it the logic assumption? Something has to be wrong. Or is it the locality assumption? This is contentious. Look at the options science has. Something's wrong with those three assumptions. Which one is wrong? Basically, science has come down, not without its debates, not completely without tendentious positions being taken. It's come down on saying it's the locality assumption. It's exactly what Einstein had feared, is what's at issue. Now, this is not to say that whatever this non-locality is the non-locality Gibson is after, but it's simply notions and intuitions. It's ideas that 20th century now allows us to play with as we struggle with this deep problem of perception. Here are some entailment assumptions handed down to us towards the end of the 20th century. There are insufficient modes of entailment, says the theoretical physicist biologist Robert Rosen. Here's the so-called modeling relation. It had been introduced in the 1800s by Hertz and refined very dramatically in the 20th century by Rosen and slightly before him others. So what does it say here? It says over to the left is the natural system with its causal structure. And then what we attempt to do as scientists, we try to encode that causal structure into a formal system. We then run our inferences, our inductive inference process, over this formal structure, and we then decode back to make predictions about the world. Well, the formal system was given to us through the recursion rule of Newton. The kind of causal structure we can capture is a causal structure which is sort of imagistically the causal structure of contacts. Billiard balls remain somewhere in our imagination a very powerful way of thinking about nature. One thing contacts another, which contacts another. Processes proceed in this particular manner. The claim of people like Rosen and others is that this entailment structure is insufficient for complex systems. And there's a problem facing modern science, and it's this problem, a poverty of entailment. And I think this is, personally, as a psychologist, struggling with these issues towards the latter part of my career, struggling with these issues, I was taught from the time I entered the study of perception that the real problem was the poverty of the stimulus. And Gibson always said, no, that's not the problem. The problem is not the poverty of stimulation. That's not the problem. He couldn't put his finger on what the real problem is, but maybe as we enter now the 21st century, we can begin to see that perhaps the real problem is the poverty of entailment. We don't have enough entailment structure to pick up complex systems. We don't have enough entailment structure to absorb what is meant by the notion of perception. The problem, as Rosen and others have pointed out, is that complex systems have irremovable impredicativities. That's not easy to say. They have irremovable impredicativities. This word, impredicativity, this word was given to science by Henri Poincaré, certainly one of the primary movers of nonlinear dynamics. Great French mathematician, physicist of the latter part of the 1800s, early part of the 1900s. He gave it to Bertrand Russell, because Russell was trying to get clear on what should be true and proper of formalisms, what should be true and proper of mathematical systems. And Poincaré wished to help out. This diagram is not brilliant, but it's not unreasonable. I want you to consider the big white arrows. Explanation in this direction, from context to system, from system to subsystems, from function to components. Explanation in this direction is what is meant by impredicativity. This direction of definition, understanding, explanation, entailment is impredicative. And it is, as you can see, a particular process where what is defined participates in its own definition. My God. No wonder Bertrand Russell was doing his damnedest to get rid of such things. But you cannot get rid of them. That was the lesson of Gödel. This is the real positive lesson. This is the true take-home message of Gödel. Gödel's take-home message is that trying to do everything predicatively is exactly what Russell wanted, what Hilbert wanted, what the great revolution of the mathematicians in the early part of the 20th century leading to the likes of Gödel himself and to Turing. What they wanted was to get everything expressed predicatively. Get everything expressed in a manner, of course, which is how we write our computer programs. Everything is written predicatively. Gödel's incompleteness theorem proves that this direction is insufficient. This is what he did, you see. Hilbert's suggestion was you just keep taking in predicatives and make them, rewrite them as predicative sentences. Keep doing it. But what he showed you can't keep doing it. There's always a huge residue. There are irremovable impredicativities. The number system, which is a complex system, cannot be captured predicatively. People like Rosen and others would like to suggest predication without impredication, syntax without semantics, is too feeble a definition. Let's look at the component assumption. And in some respects, the component assumption is nicely, I think, captured through the uncertainty principle. There's nothing special about this principle. It's very generic. The principle is straightforward. It is an expression of the fact that the nature of the thing is defined by the system composed of the thing and of the measure made upon it. It's worth repeating. The uncertainty principle is generic. It is an expression of the fact that the nature of the thing is defined by the system composed of the thing and the measure exacted from it. The thing is defined impredicatively. It is defined in terms of the whole of which it is a part. Change the whole, of which the thing is a part, and the thing changes. Here's the classic example. Take an indefinite thing and put it into the context of a position meter, and put it into the context of a velocity meter. This is how we sort of tried to give expression to this in the early part of the 1900s. This is a mouthful, but it's worth examining. The property thing defined impredicatively by P is not the same property thing defined impredicatively by V. P is the position system, V is the velocity system. The P measure that yields a definite thing, there's an entity at this position, has no bearing on the V measure that yields a different definite thing, and vice versa. These are the horrors of quantum mechanics. Better, this is the beauty of quantum mechanics. This is the logic structure of significance, I think, to many of the puzzles that challenge us. Affordances. Gibson's, perhaps, it's hard to say which is his deepest idea, though. Too many of them are too scary here. But affordances is definitely scary. It's a very scary notion. We're very good here. We're very good with this property. This is a primary predicative property. This is height. We're very good here. So we take a ruler, we take an object, and we juxtapose.
Actually, I want to say, notice how he treats the introduction of affordances as like serious. It's a serious thing, and it's very few get scared of it.
Yeah.
So you should since he treats it seriously, he's gonna thoroughly explain it.
Suppose we get height. But this is a different sort of property. This is a relational impredicative property. This surface is a jump-onable surface for this animal. And when you look at this particular problem, notice it is expressed by a relation with another object, just like a primary property. But it is actualized in relation with another object, unlike a primary property. This is affordance. This is why affordance is so damn hard for us to grasp. That is why Gibson is always in trouble. He's always in trouble. Because we're armed with the notion of primary properties in its legacy and its logic. So it's this kind of property we're armed. Where does this lead us? Are there two different and complementary physical conceptions of a macroscopic object? A puzzle that has raged throughout the 20th century. Do they sustain two different and complementary conceptions of causality? An issue sustained through the 20th century. But there's something new. Is the generalized complementarity principle advanced by Niels Bohr and certainly championed by Howard Patti in the United States, theoretical physicist who's worked on the origin of life property? Is this a generalized notion such that we should treat it as a matter of ontology, not as Niels Bohr thought, as a matter of epistemology? The matter assumption. Active self-motion, self-cause. Here's Belousov-Zhabotinsky reaction. Take a liquid which abides by these equations. Put it in a beaker, it will oscillate between the color red and the color blue. Look at it from above in a petri dish, and it will show the waxing and wanings of colors and patterns. When Belousov first reported this, people would not publish it. They said it's impossible. It's an impossibility. 1940 sometime, I think, when Belousov was trying to publish it. 1940. Could not get it in any journal in the world. Impossible. We now all accept. Not only is it possible, it's probably dominant. It's an autocatalytic process. You notice that that piece of the equation which has x in it is such that when it combines with y, you produce more x. And therefore, you keep producing more of what you have. This process gathers in energy of matter and it trims its properties. It is a very interesting structure, autocatalysis. It's more like formal causality than it is efficient causality. It's unlike things that we have previously worried about a great deal. And the implied form of self-cause is an impredicative loop. I think arguments such as those of Harkin and others suffer because what people have great difficulty with is precisely this circular causal process. It's an impredicative loop. That's what makes it so hard for us to come to terms with. Interacting parts produce the Belousov-Zhabotinsky spiral. They produce this emergent distributed whole, which then constrains the interacting part. Matter assumption 2, the one I used the other day. I like this one a lot. This is turbulence, the irony of turbulence. No, not the other one, not this one.
I have a lot of notes on this, by the way.
Was on his death.
Like this whole, like everything he's saying here, his whole lecture here, actually I have a lot of notes on this in the organism environment and on turbulence. Like if you control it for turbulence, there's a lot of stuff. In there, maybe it's not in that note. Maybe it's in a there was so much stuff that I put it in a different note. Maybe I think maybe I put it in like box 4, like the note called box 4, like multiple O's. If you look in there, you might be able to find it. Like the stuff on turbulence. There's a lot of stuff that I put in there. Yeah. Cool.
He was asked by his buddies, which question will you ask of God when you get to heaven? He said, I have but one question for God. What is
He's using anecdotes here. I think it's a great tool for engagement and such things.
Yeah, I have the anecdote. Like I have the whole anecdote that he gives here in like with more detail.
Yeah.
In my notes.
I think humor is great for
the irony of turbulence. Yeah.
Yeah.
turbulence. And the reason he saw this as because look, see, that's laminar flow. It looks very neat and very tidy. And then this is turbulence as you speed up the flow of water. Why is this the way it is? Because in a non-linear process, every part connects to every other part. And those parts make more parts. That's why turbulence was ironic. Turbulence arises from the fact that all the parts are speaking to each other. There's implicit correlation rampant throughout the system. That's the irony of turbulence. That's why it's been so strange.
Yeah, I literally quote Turvey
subsequent
on this. I quote this lecture in my notes, like what he's saying now.
Deathbed was asked, what will you request of God when you get to heaven? He said, well, I won't embarrass him with that turbulence thing. So here we are. I'm trying to suggest that direct perception lives, perhaps, at least if we're going to try to understand how to lay hold of it, it lives perhaps in notions like these: non-locality, self-motion, impredicativity. It is not addressable through the ideas of the 17th century. It may be, only may be, capturable by the ideas of the 21st
Oh man,
century.
it's too mystical, man. Those terms,
What are the
man,
expectations
too
for
mystical.
perceptual theory?
Turbulence, bro. Non-locality, bro.
What the hell?
Impredicative.
Too mystical. Oh my god. These recorded events that you can reproduce. Too mystical. Convection cells? Haven't
Too
seen
mystical,
one.
man.
Haven't seen one with my eyes. It's too mystical to me.
Yeah, but they don't. There's a double standard. I mean, if that's the standard, they definitely don't hold that standard for their fucking their equilibrium reversible mechanics. Yeah.
Yeah.
Perceptual theory will be abstract and not visualizable. You're not going to be able to draw nice little box diagrams in order to give expression to perception. It's not that kind of thing. It's not like it. It's exactly as the early part of the century we began to realize, once we were able to get rid of the ether notion, that took a long time, we realized that no more.
The ether. Look. This.
Now that's some really, really, that's some mystical topic.
Oh yeah, the ether. That's the real thing.
Yo, but Zulu. Oh man, it's crazy, right?
That
Zulu's
thing
like
we just
all
invented
for
to
it.
explain this thing. That's the real thing, actually. Convection cells? I don't
That's
think
not
so.
mystical.
Sounds too
That's
mystical
not
to me.
mystical. This thing we don't even know what it is. Like we literally explicitly say that, like, it's just, oh, maybe we'll find out one day what the ancient Greeks thought all so long ago, the building blocks, the fundamental building blocks. Yeah.
Did we need machine analogs? Don't try to visualize the economy. Laws and principles, not mechanisms and machines. This was brought up, I think, in talks during the week.
And
It's not simulated.
Oh, sorry, if I'm not, I wasn't fucking close to my mic. And it's funny, because if you look at the videos that they make on that, right, the ether stuff, they literally start with, like, the ancient Greeks and, like, their theories about, like, you know, like a little stuff, you know?
Oh, the ancient Greeks, the people who ate rooms and hallucinated.
Who thought the fucking sky was, like, a crystal lattice with, like, these crystals, like, fucking just, like,
The people who thought
these
that
giant crystals.
motion didn't exist.
Yeah, bro, the people who thought motion didn't exist.
It has to be reducible to predicative statements. And Gödel's theorem says that's not going to occur in complex systems by lines of argument developing in the latter part of the 20th century say complexity is defined by irremovable predicativities, not artificially bounded. It's constituted by fundamentally context-dependent parts. Therefore, no explanation by construction. That also came up during the week. No explanation by construction. You can't build a thing and say, oh, now I've explained it. You're not going to build it. No explanation by construction. They're parts of context dependent. No fixed set of states. So we've always assumed that nature is to be understood through a fixed state space of some kind. But as we probe ever more the nature of complex systems and the like, then we have a new option, no fixed set of states. The variables are up the graphs, ones that matter. And you've seen a lot of that this week. And finally, no explicit material processes. Instead, these are abstractions of the enfolded dynamics. There's some weird stuff here. Only if, however,
I like how he puts it. I have to use that. No fixed set of states. It implies that the variables are up for grabs. The ones that matter. I like how he says that.
Yeah. There's like a wide range of problems you can tackle.
I'll definitely have to use that.
Yeah. It's like when I integrated ecopsych, like I started seeing a lot of these problems that I encounter in my daily life. Is like, oh, I can like investigate it now. I have the terminology to do so. I can study that now. When earlier I was like, I was basically a rationalist about it. I had a pre-compiled answer for everything.
Right.
Or like I just didn't think about it. I just didn't see a problem there. I guess I had an answer for that. So
The idea is that we're given to us by Galileo, Descartes, Newton, John Locke, and I've forgotten his first name, Boyle. Thank you.
Yeah, you had the answer that didn't require you to do any work.
Yeah, just adopted the answer from like a truism.
Yeah, but remember the discussion we were having on zero-sum metaphysics, I think? Zero-sum metaphysics, right?
Yeah.
And yeah, that's a good point. That you had an answer, but it was an answer that you can like that didn't require you to like do anything
How did you get to that answer?
Right?
That is the question.
Right. But it's independent of that. It doesn't matter how you got to it, right? In order for you to answer, right?
Yeah.
The answer doesn't require any work from you. You get what I'm saying?
Yeah. But like
it's sort of just like you have that,
to
I think when we were talking about what we were talking about in the zero-sum metaphysics, like the discussion, right? I think I was trying to make a point here right now about like that was something that was missing from the discussion, right? Like the opposite, like the negative here, or like how it's like, oh, you already have the answer. Like it's like, okay, it's easy because you already have this answer, right? Like anybody can have this answer. That it's like you don't have to work to get the answer. You don't have to do anything, right? And that's why, this is the point, right? And that's why remember we were talking about why people see an answer, like they see that an answer requires work. They see that knowledge requires work, and they just like they're against it. You know what I mean? They're like because they already have this answer that doesn't require any work. You get what I'm saying?
Yeah, I think it's ties into psychological inertia, where you're so used to having everything done for you that you're repulsed from actually doing the work. So, and I think it's actually also a method for catching rationalism. When you
no, but it's like they think like that it requires work makes it like unreal, less like not less real, not objective. You know what I mean?
Yeah,
and that's because they already have this answer that doesn't require any work for them.
Yeah, exactly. I think for like catching rationalism in your own thinking, you can ask yourself what was the work that I did to acquire this concept or something like that.
What did that cost me?
Yeah. How did I acquire
it's like
this
yeah,
thing?
yeah, like values, right? Values make action possible because they're purchased with action, right? They cost action, right?
Yeah.
That's why they make action possible, right? They're bought with the currency of one's life, right?
Zetetic always does this thing where he offloads the work on you to disprove his positions that he just adopts.
Yeah,
He
but
went
I think
to
check your premises.
an Rand convention
Check your premises.
sometime earlier, and
I
now
think I think what check your premises. Yeah. Well, I think what check your premises really means, like, with what we're saying here, is just like, what did this cost me, right?
Yeah.
Does it actually have the power that I'm attributing to it? You know what I mean? Right?
Mhm.
Or because if it has that power, like, it costed something. You know what I mean?
Yeah.
So what did it cost?
Zedek went to this Ayn Rand convention, and he is like parroting this idea that living is aesthetics, you live for aesthetics, everything is aesthetics and such. And it's like it's not exactly exhaustive of living. And his
Yeah, it's not exhaustive.
yeah.
It certainly runs through everything.
Yeah.
That's philosophy.
But his epistemological process, from what I've seen, is just getting told that he's stupid, and he just blindly adopts whatever is said after that. And he doesn't even internalize it at all. He just parrots it and doesn't understand how what the logic behind it is. Because this aesthetic point, now he thinks that living is aesthetics. That is all that living is, when it's not exactly exhaustive of living. And I think in that Ayn Rand convention, I don't think they even said that it was exhaustive of living. I highly doubt that. I think it's just they said that it was a big part of life. I think it was just that. But he needed so much something to adopt, to cling on to, because he doesn't want to do the work. So he just starts having these positions. And it's your job to disprove his positions for him so that he can adopt something new. Like, he certainly doesn't adhere to anything like, you could say he has no he doesn't cling to sunk costs, but also he doesn't have any substance behind his positions as well. So he just
I mean,
picks them up and drops them
I
on a
have
whim.
yeah, I experienced him when I was debating about IP law, and he was like, "Oh, you could CC40 and patent," and I was like, "Bro, do you know the difference between a patent and a copyright? They are two different things in law." You know, like it clearly showed me that he didn't knew what he was talking about.
I think
Oh yeah, bro. That was a good lecture. What do you guys think about the lecture?
yeah, it's a great lecture. You can take a lot from it in terms of ecosec and then in terms of pedagogy, because it's like so nicely done.
It is nice, but I haven't thought much attention of it because I was cooking the process like G was. So yeah. But I mean, for the little I was able to grasp, it was good.
Okay, anybody else? No deal.
Okay, I'll stop recording now.